Thank you, Sergeant. So good morning, everybody. My name is Sebastien Ziegler. So as Sergeant mentioned it, I'm from an organization which is a kind of unusual stakeholder in research project because we're at the same time user of research results and leading research projects, coordinating European research projects. So it's a kind of mixed functions or multiple functions according to the different projects. So the idea of this presentation is to give you maybe different perspectives on end-user role in IoT research. Just two figures to start that most of you know already. The evolution of the IoT is tremendous. We expect, so there are different projections. Nobody is Cassandra, but Ericsson, for instance, anticipated 50 billion devices by 2020. Research groups like, or I would say market analysis groups like Mason anticipated an evolution from 100 million M2M connection in 2011 to 2.1 billion M2M connection in 10 years time from now. You know that since last year we have more M2M connection than human-to-machine connection on the internet. So we're really in a paradigm change in terms of technological development, deployment, and use. If you take this really nice drawing from Libellium that some of you know regarding one specific product, wireless sensor modes developed by Libellium, you see already with one kind of device the large number of applications you may address. So from environment, waste management, smart cities, agriculture, and others. If we look now at some of the main drivers for IoT evolution currently, one of the key drivers now is agriculture. It doesn't appear as a direct driver for many researchers, but indeed it's perceived as one of the major future drivers for IoT development because there's a huge potential to increase productivity, to increase natural use, allocation of natural resources such as water, energy, fertilizer for agricultural production. And it's of course a huge market for the IoT in terms of business, of volume, and of number of IoT devices. You have here just moisture sensors, so you will have this nanotechnology more and more embedded, very smart, tiny sensors or IoT devices which will be used in agriculture. Another key driving force for the IoT development and adoption is smart grid. You don't really see it on the upper part, but it's a picture of a city with a blackout. And as you know, in Europe, we already faced some very dangerous period of time, episodes, as we have a growing consumption of energy, which is twice as big as a growing production of energy in Europe. So we still have some margin, but the margin is narrowing down. And the problem is when you have a peak. So you have suddenly a lot of people starting to watch TV because there's a soccer cup, and the smart grid is not prepared for that. And then if you have an overload of demand, you may have a blackout. Another key driver is e-health, and some of you are working on e-health or had some projects related to e-health. And as you know, Europe is an aging population. We will have more and more elder people. We will have more and more people who will need support, some medical assistance. And the choice is whether you want to have everybody in a hospital, and, which is not comfortable, which is not pleasant for the patient, but which is very costly. Or if you try to find solutions to enable people to remain at home and to get some remote monitoring, remote assistance, remote support. And there again, you need IoT technology for that. So those are three of the main drivers. And the three drivers are paradoxically directly related to human beings, to society, to societal needs. So even so, if you are moving from an internet which was more human-centered to an internet which will be more machine-to-machine oriented or focused or interconnected, we will have more and more to take into account in the research cycle the finality of the development. Why are we and what for are we developing new IoT technologies? Who will be the end users? Who will be the beneficiaries of such technology? So in IoT currently, you have many key challenges to be addressed. Some are very clearly identified, like interoperability. Since 2005, it's perceived or considered by the ITU as the main barrier to IoT development. Scalability, if we're moving from a world of few interconnected sensors or local mesh networks to 50 billion interconnected devices, you need to address scalability issue, you need to address security and reliability issues and find solutions for that. But what is often forgotten, you need also to address other kind of issues for IoT. And it has been presented just before, the issue of privacy, for instance, the legal risk with your technology, even for research, pure research purpose. And as it has been mentioned, for European research projects, all the new projects are scrutinized through the angle and the glasses of ethics and privacy and personal data protection. So there's an issue of adequation and alignment between the development, the technological development, and the societal needs for those technologies. User acceptance is key too, again. If you want to develop a technology which will remain in your labs, that's not an issue. But if you are really trying to dedicate time, efforts, intelligence to develop solutions, it would be useful to make, probably you wish those solutions to be then adopted by the society, by the market, by companies, by end users, or whatever it is. So one of the questions is, what is the role of the end users in IoT research and development process? And what kinds of relationship you can envisage in those, in IoT R&D project? What I will do is to try to align different schemes through different projects we have been involved in, trying to illustrate different forms or different paradigms of cooperation with end users. So maybe a first one, the easiest one, is that you have many end users. It might be a company, an individual, a person, a group of persons, an NGO sometimes, facing a problem and trying to solve a problem by itself. So, and bringing innovation, bringing new solutions. So, for instance, in our case, we were working a few years ago on a project of new building in Geneva to support delegates attending UN conferences, delegates from developing countries. And while we were working on this project, we had a key concern as a foundation. So we are a foundation, by the way, and recognized as research center by the European Commission. But we had a key concern is that if we were involved in building a new construction in Geneva, the issue of impact on the environment and sustainable development was a key issue, a key concern for us. As you know, buildings, constructions represent about a third of greenhouse gas emission in the world, according to IPEC. It's about a little bit more than 41% of energy consumed in Europe. It's more or less the same figure in other parts of the world. So buildings are not a trivial issue. It's really, if you have a building, you have an impact. You will have an impact on your environment, locally and globally. So the issue for us is, when we started to work on this project, it was, there are many solutions, very caustic solutions. What could we do in order to turn buildings into smarter, more energy-efficient environment? Including existing buildings, we're renting other places, and it was interesting for us to see what could we do, what could technology bring in terms of added value to address these issues, this specific issue. And we started to work on trying to develop new concepts, new visions, and at this time we were working on the IPv6 development. We're part of Internet Society too. And what we realized when we started to really analyze building automation solutions, that you had a lot of silos, a lot of solutions, but a high lack of interoperability. You have a lot of fragmentation, deployment costs, a lot of hurdles, many hurdles to turn a building into a green and smart building. So we were trying to look for a powerful integrator, trying to find a solutions to integrate those different components together, and the natural candidate for us, from our point of view, was IPv6. So why not to use IPv6, which was initially designed for computer networks, to interconnect all kinds of devices and components? That was 6-7 years ago. So we started to work on that, and we started to work on concept, trying to imagine a building where everything could be connected through IPv6, using IPv6 as a common denominator, as a kind of lingua franca, something which would bring together the different elements together, not only building automation components, sensors, but also human-to-machine interactions, access to web services, and trying to integrate all that together. And then we developed this concept of smart IPv6 building. Another case, and it came just after this project, we wanted to go further in this analysis and in this option, trying to explore further, deeper this option. And we joined a consortium with University of Applied Sciences, Western Switzerland, and 2 SMEs to see how we could, in practice, integrate devices, existing devices like heat valves, like sensors, like access control mechanism and others, or lights or smart lighting system, which are already using different communication protocols. How could we integrate them together through IPv6 and use IPv6 as, again, as a interoperability enabler or an integrator? And the project ended up with a solution which we use in other research projects, a kind of I would say multi-protocol control monitoring systems, enabling intelligence distribution among different components which were initially not interoperable. Then you may have other schemes. For instance, end users playing a more active role in designing the research project. That's what we did, for instance, in the HubNet project. HubNet project is a European research project which was trying to develop and explore the potential of IPv6 for wireless sensor networks. So it contributed a lot to co-op development, to some new standards like lightweight M2M. We had partners such as Surgeon, but Zach Shelby from Senzations working the project, different universities, CTI in Patras in Greece. And the idea was really to say, okay, let's imagine now that we have a building with wireless sensor networks, how can we efficiently use IPv6? Knowing that, as you know, IPv6 has a large overhead, so you will not use IPv6 as such for wireless sensor networks. You will use 6LoWPAN, but how we can go further, how we can optimize the way we integrate those different components together through mesh networks and mesh networks technology, while using the potential of IPv6 to integrate them globally into the internet. That was a really nice project, but in this project, what is interesting is the scheme that we adopted. So we started by identifying end-user needs and expectations in the project, in the frame of the project. So the project was designed as such. Then using end-users, delegates, for instance, attending UN conferences, to identify or propose solutions or needs that they would have, and to come up with a certain number of potential end-user application and use case that we could work on in the frame of the project. So that was the first part. The first step in the project was really to start from the end-user needs, end-user perspective, and then to work with the research team. So you have the end-user side on the left side, and the research team on the right side, and then a lot of interactions, developing new solutions, identifying new use cases, and then ending up the project by end-user validation. So moving back the solutions to the end-user and testing it with real end users. So in the frame of the project, we selected finally 12 different use cases in different domains, such as local adaptation to present, which is a nice one, electric device monitoring, and we must pay credit to a very nice Serbian designer and to Surgeon for hiring him. We had some nice pictures, or user awareness, so trying really to address real needs from the society, and not just our perception from a lab perspective. Then we deployed it in different locations with real end users and with the partners too, in Patras, in Edinburgh, in different places, and we tried to collect end user feedbacks on what has been developed. And we had really interesting, I will skip maybe the details, but nevertheless, what was quite interesting that it's maybe not directly related, but there might be a correlation. The fact that we really tried to address end user needs and requirements turned the project into a rather successful project in terms of outreach and dissemination. Having partners like Senzations too, who were playing an active role in standardization process, enabled most of the outcome of the project to be disseminated and reused in other processes, including in OMA and in other standardization bodies. So and we got some feedbacks from the end users, the impact of that's some aggregated figures. We had more detailed figures on the different use cases and the impact on comfort, the impact on energy saving, and so on. Then you may have in the Internet of Things another issue, which is related to the transversality of the Internet of Things. If you are working in a specific domain like e-health, then you can easily define the end user requirements. Now, in the IoT6 project that we are coordinating, which is another European research project, the idea was to research again the potential of IPv6 for the future Internet of Things. And based on that, to develop a highly scalable IPv6-based service-oriented architecture for the IoT, and to explore innovative forms of interactions with different components of the Internet of Things, such as wireless sensor networks, tags, mobile phones, and so on. So the idea was, on one hand, to work on a horizontal integration of the IoT, trying to bring together the different silo or subdomains of the IoT, at the same time to work on a vertical integration between the IoT and the cloud. So it was a really nice project. But then one of the issues in terms of end users, as the project wanted to have practical outcomes for the society, again, not just a few publications, a nice demo in a lab. We really wanted to have a project which would be useful for the society. The issue was, so that's a consortium, with a nice consortium, but was to have a good industry advisory board, to bring together different stakeholders who could be interested in using such technology, or at least who would be able to provide us feedback on how to align our research on real needs, and not just to develop something which is nice from our perspective, but which would be irrelevant from our perspective. So we have an industry advisory board with companies like Cisco, Philips Lighting, Somfy, CIAT. We have ETSI, which is a standardization body, European standardization body, SAP. We had the chance and the honor to have Vincent, the father of the Internet Protocol and VP of Google, working together and coming together and giving us their feedback, their vision on the project, and saying, oh, that's interesting, oh, you could do some use case on this topic, or you could address this issue, or you could go in this direction. But what was quite interesting, and what was a kind of challenge for the project, is to have partners who had completely different visions. SAP and Philips Lighting have different visions on what is the Internet of Things, even the conception, the definition. So there's a work to be done not only between the research team and the potential end users, but among the end users. I'm trying to have a nice panel of diverse people, diverse stakeholders, and trying to work together with them in order to identify some common grounds for the future, for the roadmap, in terms of research roadmap. Then you have other projects where end users will be more a research topic, a focus of the research. So you will have during this summer school societal project, which will start, the kickoff, which is typically a project which will focus on end users. How can IoT be adapted to end users' needs? So in our case, we are coordinating, we are part of, not coordinating this one, but we are partner of ERIT project, which is a European research project working on audio monitoring for smart buildings and smart cities. So, again, I will just check the time. I will skip, I will not enter too much into the detail of the project, but the idea is really to try to say how can we better use audio monitoring in the context of IoT environment and IoT technology. And we have two test beds, one which is SmartSantander, so you've heard about it. The other one which is HubNet, which is the part of the HubNet test bed which is run by us in Geneva. And the idea is to do a certain number of experimentation with real end users and audio monitoring. But then you have really nice application, use cases. Again, it's really, you can explore, be very creative, and that's really nice, it's stimulating. You have a certain number of technical challenges to be addressed, but then you have also a certain number of societal challenges to be addressed, including privacy issues. It has been mentioned, end user acceptance. Even if we respect privacy obligation internationally, regionally, locally, or nationally, we may still have some negative reaction by the public, by the end users, which will make the solutions not only not acceptable by the society, but you may have a media campaign. Somebody say, oh, SmartSantander has some big brothers. Or NSA is watching SmartSantander citizens. So you need to be very careful, including in the real, since the very beginning of the research cycle, to anticipate those risks. End-user privacy, for instance, if we take this example, is a very complex notion because you have different legal obligations provided by international conventions, regional obligations, directives from the European Commission, national legislations, but you have a subjective perception. My perception of privacy is not the same as his perception of privacy. I may consider that, for instance, it's completely open to share my revenue with anybody and to post it on the internet. But he may consider that something really private. I may consider that speaking with my friend or meeting a friend in the street at 3 in the morning is something which is of public, which has no privacy issue for me. But I may at the same time consider that's my privacy right to not disclose where I was, when I was where. So complex issues. So then again, you need really to work with end users. So for instance, in IRID, we launched a survey with 1,000 people who were interviewed across Europe, in 5 different countries, trying to get feedback from the end users, and really trying to not only work with end user, but to study end user fears, or suggestions sometimes, or ideas and requirements. So really having a high focus in the research on the end user requirements. Then you may have other models, which are, for instance, a project will start coordinating a new European project in October, which is named IoT Lab. And in the case of this project, we try to go a little bit further. The idea is to research the potential of crowdsourcing for the IoT, in particular for IoT research, or IoT research infrastructure, using existing FIRE testbed or research lab in Europe, and trying to interconnect them together and to interconnect them with crowdsourcing resources. So people who may have a few sensors, but also people who are ready to upload a small app on the mobile phone to enable not only to use some of the data or sensing data of their mobile phone, but also to communicate with them, to interact with them. So the idea is really very simply, you have existing test beds, but which are closed lab, or sometimes more open test beds, but which are fixed and already well-designed infrastructure, and to enable interaction with people we don't know, and to see how we can bring them together, how we can address the reliability of the information, how we can address technical integration, but also the end-user perspective and motivation. So by the way, that's a project where we have on one side technical partners, technical universities, but we also have a business faculty from Southampton and 2 partners who are really focused on end-user interactions. So that's a kind of scheme. Again, you have SmartSantander, so the part which is more in England, HubNet, WiseBed, individual participants, and different research that will use the same platform to address, again, not only the technological dimension, but the cross-domain interaction of the IoT with the society. So I mentioned tools, and then it ended up into a really interesting scheme that we'll try to explore in the frame of the project, is really using the crowd not only as a resource for sensor or data for the research, but really trying to explore a kind of new paradigm of research where we'll use this technology to enable the crowd to propose, to submit some ideas, research topics, to see what will come. Maybe someone would say, oh, I would like to find a solution to combine my lighting level with my mobile phone, and when I'm nearby, I can adapt the lightings, and when I get out of the room, then the lighting is switched off, or is the data or the temperature of my heater may be adapted to my personal profile, for instance. All kinds of ideas will come. And the idea is then, based on those proposed ideas, to enable the crowd itself to assess it. say, oh, that's a very good idea. Oh, no, I don't like it, but this one is a very, very good idea. So we should try to, and then you have easily a ranking of the different proposals which are made and provided by the crowd. Then, on the other side, you have research team, which will select among the best ideas, the best ranked ideas. It doesn't mean that the first idea will be automatically explored, because it may be not realistic or not relevant for the researcher, but at least we can already align and give a direction to the research in line with what the crowd is interested in. And then to select and to develop, to do development, to coding and so on, and then to testing. And again, then the crowd comes again into the loop. Because the idea is to test and to have feedback from the crowd, to have assessment from the crowd. So to test and to get assessment. And then, again, you have a kind of, you could have, at least, and that's what we'll try to explore, kind of virtuous cycle with iterative loops of research adaptation and always dialoguing directly with the crowd as a partner in the research process. Then you can turn on, get new proposals and so on. Skip that. I think I will reach to my 45 minutes. So just the last slide. So the idea was just to illustrate the fact that end users, first of all, are key components for future IoT research. Even if paradoxically they will be more and more distant from the lab, because you will now focus on pure technological issues for most of the engineers and research teams. But at the same time, they will be the key element for the success of your technology. So you really need not only in a, we say, altruistic approach to say, oh, it's important to take care of the society, but for your own research, it's important to align your research with something which is useful for the society. So you need to really take into account the end users. And then to understand that end users can play many different roles in the research process. There can be final users, so the finality, the purpose of your research. There can be a source of requirements to clarify what are the requirements. If I'm doing e-health project, I need to have patients, to have people who have an expertise from the end user side to allow me to understand what, beyond the privacy norms, what would be the requirements to handle properly those, the data, to have feedbacks from physicians, from hospitals, from different sources. Then societal and legal framework. Solution co-design, as I mentioned, R&D evaluation. It's important to have end user, at least it's an opportunity for you to work with end users to get feedback on your project and your development. Market penetration, again, if you want to develop a solution which has a good chance to be adopted by the society. So either it's a free solution, it's open source, so that's not an issue. You just post it and you hope that somebody, a community will use it. But if it's a technology which requires some investment to be produced or manufactured, then you need to have some business model, and you need to make sure that someone will be ready to pay for your technology to get out of the lab. And research funding, again, for the European Commission. There is an increasing push to align research projects with the societal needs, whether it is in terms of job creation or in terms of non-profit functionalities or benefit, such as environmental monitoring or educational purpose and so on. So here it is. I don't know if I managed to keep my 45 minutes. I don't know. Is it good?
You were quick about that.
Thanks. So thank you. I don't know if you have any question. I didn't give much time to such questions, but otherwise I'm available bilateral talk. Thank you very much.